All right, welcome back. Hononegah Honors Algebra 2. We're going to start a new chapter today, Chapter 5. Chapter 5's got a little bit of challenge to it, so we'll see how this goes. 5.1, nth roots and rational expressions. Basically, when you're taking the nth root of anything. Now, obviously, you've done square roots before, and maybe you've even done cube roots, but you can technically do any root greater than 1. So it's a situation that, and I'm going to show this to you. Anytime you're taking the square root of something, it's equivalent to taking that number, or the radicand, raised to the 1 over nth power. So that's what they're saying up here is nth root of a is equivalent to a to the 1/nth power. So notice the square root of 2 is the same as 2 to the 1/2, or the cube root of 3 is the same as 3 to the 1/3. So I want you to pull out a calculator right now, and I'm going to do the square root of 25. So everybody knows that the square root of 25 is 5. But what about 25 raised to the 1/2 power? Now, please be careful depending on how old your calculator is. If you type in 25 up caret 1/2, it's not going to like that because ultimately you want both of those to be in parentheses. So it's 25 raised to the 1/2 power. And you're going to find that it's 5 because when you're taking the square root of 25, it's the same as 25 to the 1/2 power. Now, I hesitate to pull this down, but I'm going to talk about it just a little bit. So anytime you are taking, sorry about the interruption there. So this basically is talking about when you decide to solve something and you want real answers, okay? Real answers. If you have a negative under the radical, that wouldn't be a real. So there's no real answers if the radicand is negative. If you have, and this is talking about an even root, okay? So you're talking about square roots, you're talking about fourth roots, you're talking about sixth roots. You can't have a real answer if there's a negative underneath there. Now, if you have 0 as a radicand, doesn't matter the root, whether it's a square root, a fourth root, or sixth root, you'll always get 0. And then again, this is only if you are solving. So I'm going to make sure we talk about that. So if you are solving and you have a radicand that is positive, now you're going to get a plus or a minus. Just like when you got a plus or a minus when you did the square root of both sides, it would technically work if you did the fourth root of both sides or the sixth root of both sides. So any even root of both sides of an equation is going to be a positive negative. So it's just not square roots. It can be any root. Now, if it's an odd root, so you're talking about a cube root or a fifth root, there's always only going to be one answer. And you can take an odd root of a negative, and you can take the odd root of 0, and you can take the odd root of a positive, but there will always only be one answer when taking the odd root of both sides. So even root to both sides, 2 answers if it's positive. Odd roots, always 1. So all they want you to do is go ahead and use a calculator and find the fifth root of negative 243, or find the eighth root of 256. And so pull out a calculator. I'm going to do it right now because I'm going to show some of you how to do this. And there's 2 ways that you can type this in your calculator. You can type it in as negative 243 raised to the 1/5 power. Now be careful, anytime you have a negative raised to a power, I would recommend that you go ahead and put it in parentheses. This one wouldn't have mattered. Okay, and the next one you could go 256 raised to the 1/8 power. I'm going to show you both ways to do this on the calculator. So now I pull out my calculator, and so I want negative 200, the fifth root of 243. Now I have a newer calculator, but if you hit second math, sorry, just math, go down to the 5th option where it says X root. So hit enter there. And depending, math, number 5. Depending on how new or old your calculator is, you might have to hit the 5 and then hit math. This one is fairly new, so I can hit 5 and then arrow negative 243. So that's the fifth root of negative 243, and the answer is negative 3. Now notice that I can do this in another way. So parenthesis, negative 243. So I'm taking negative 243, and I'm going to raise it to the 1/5. So 1/5. And again, depending on how new or old your calculator is depending on whether or not it will keep it as a exponent. And you hit enter. And look, it's the same answer. So the fifth root of negative 243 or negative 203 raised to the 1/5 power is still negative 3. And again, if you have an older calculator, and I don't think it's going to let me write on this, but I'm going to go back here, you would need to do this if you had an older calculator. Next one, the 8th root of 256. Let me go back to my calculator here. So math, option 5, 8th root of 256. 2. Or if you wanted to write it as 256, and again, this one you didn't need the parenthesis, but I kind of get in that habit, raised to the 1/8 power. It's also 2. Next one. Now, you don't always have to have a 1 over n. Okay, there are other rational exponents. There are other exponents. If you have 3/2 or negative 1/2 as an exponent, what this is saying, the bottom number is the root and the top number is the exponent. So if I had, I'm just going to write this with an x here, x to the 4/5 power is the same as the 5th root of x to the 4th. So the bottom number is the root. Just like up here when you had the cube root of something, it's 1 over 3 because again it's x to the 1st. Now if you end up with a negative exponent like this one, negative 1/2, that actually means the reciprocal of. So if I had x to the negative 1/4 power, and I'm going to change that, I'm going to make it negative 3/4 power. That's taking the 4th root of x to the negative 3rd. Well, you can't leave it as the negative power. So anytime you have a negative power, it technically means the reciprocal. Okay? So the negative power means you would flip it. So instead of it being on the top, you would actually move it to the bottom. So it's the 4th root of x to the 3rd power. Now, we're going to talk more about this as the chapter goes along about radicals in the denominator, because all kinds of rules that you're going to have to worry yourself about when you have radicals in the denominator. So now, evaluate this expression. You can use a calculator. I'm not going to here. 64 is 4 to the 3rd, and so I'm just going to do some exponent rules. So then, anytime you have a power raised to a power, and again, we're going to talk more about that as the chapter goes along. And so then 4 to the 4th power is 256. Let's check myself. Let's see if I'm right. So I'm going to go to my calculator now and type in 64 raised to the 4/3 power. Let's see if I'm right. So 64 raised to the 4/3 power. Hey, look, I got it right. Next one. Now, again, I am not going to use a calculator on this one. Negative power means the reciprocal. So it's 16 to the 5/4. 16 is 2 to the 4th. Exponent rules say when you have a power raised to a power, you multiply the powers together. And so I'm going to guess that the answer to this question is 1 over 32. Now, let's see if my calculator says the same thing. So I believe it was 64 raised to the negative, make sure you use the negative sign. Whoops, 16, sorry, raised to the negative. I'm going to go back. So 16 raised to the negative 5/4. Now it's going to give me a decimal. I don't want that decimal. There is an option to turn decimals into fractions. Those of you that don't know this, hit math, and then the first one is frac. So that is basically taking your answer and turning it into a fraction. And look, it's 1/32. Now they want me to actually use the calculator and get a decimal answer. And I don't know, I don't want to go back and forth to the calculator now, but it's saying evaluate the expression using a calculator, round your answer to 2 decimal places. So it literally just wants you to take 7 and raise it to the 1/4 power. So you might want to hit pause, go ahead and do all of these, and I'm just going to write out the answers here in just a second. All right, welcome back. So now I'm going to write the answers to all of these. So the first one, 7 raised to the 1/4 power is 1.63, rounding to 2 decimal places. The next one, 10 raised to the 2/5, 2.51. And then the last one, 11 raised to the 2/3 would be 4.95. So if you have any questions on that, make sure you talk to your teacher about how to type it into your calculators. Next, solving with. And again, the one thing I would tell all of you is if you're going to take the odd root of both sides, there's always going to be one answer. If you're going to take the even root of both sides, there's always going to be 2. So I'm going to divide both sides by 5. So 32 divided by 5 is 64. Now, just like when you took the square root of both sides, you actually could take the nth root of both sides. So I'm going to take the cube root of both sides. Because it is an odd root, there will be one answer, and the cube root of 64 is 4. So don't just put plus or minus on every single question. The next one, I'm going to take the 4th root of both sides. And yes, this will be a plus or minus because when you're taking the even root of both sides. Now, remember, we talked about factor trees. You need 4 of a kind in order to simplify. This one does not simplify. So this would still be the 4th root of 24 because there's not enough 2's to simplify. And we're going to get into simplifying nth root later. So just leave it for right now, the 4th root of 24. Because ultimately, the 4th root of 24 does not simplify. This one's an interesting question, very real life question. The hospital purchases a machine for $75,000, and the hospital expects its useful life to be 12 years, at which time the value will depreciate to $15,000. The annual depreciation rate R is given by the formula, where N is the useful life. So N is the useful life. So I have 1/12. S is the salvage value. In this case, you're talking about the depreciating to 15,000. So 15,000 is the S. C is the original cost. So 75,000. So think of this from a business perspective. You expect something to last a certain amount of time. How much will it be worth when it's done? So what is the R? What is the rate of depreciation for this particular question? So I'm going to go ahead and pull out my graphing calculator and type this in. So go ahead and hit pause. So welcome back. All right, here we go. So I typed this in and got 0.1255. So you're talking about a 12.55% depreciation rate. This happens a lot with vehicles. It happens with and then you also get an appreciation rate for certain different things. But ultimately, there's a rate at which a car or a rate at which an item can go depreciate in value. And ultimately, in this particular formula, is dealing with depreciation and salvage amount. Your homework assignment tonight is out of the book. If you have any questions, make sure that you talk to your teacher, and good luck.